Hi, and welcome to the Embedded Spare series on the official YouTube channel for Hub 360. We're a Nigerian-based company that creates and assists people with their embedded system projects. We also provide the components you need to bring your embedded system ideas to life, whether you're a student, a hobbyist, or just getting into electronics. If you enjoyed this video, please give it a thumbs up. You can find the link to all the components and the code used in this video in the description box below. I'll be showing you the step-by-step process on how to design and program this simple circuit. And with that, let's get right into the video. The components we'll be using are 3 LEDs, red, yellow, and green respectively, 3 to 20 ohm resistors, an Arduino Uno, a breadboard, 7 jumper wires. Let's begin by placing the LEDs on the breadboard. Take note of the positive and negative legs of the LEDs. And remember, the anode, the longer leg, is the positive, and the cathode, the shorter leg, is the negative. Place the LEDs horizontally on the breadboard. This is because the vertical rails are connected internally, while the horizontal ones are not. Next, we connect a resistor to each anode. I'm using a 1 kilo ohm resistor, but you can make use of a 220 ohm resistor. Now connect all 3 cathodes to the ground rail. Note that the ground rail on the breadboard is the one that has the negative lines, and only the positive and ground rails on the breadboard are connected horizontally. Next, connect the other leg of the resistor of each LED to a digital pin on the Arduino Uno. The red LED to pin 2, the yellow LED to pin 4, and the green LED to pin 6. This setup allows current to pass through the resistor first, reducing it before it reaches the LEDs. Lastly, we connect a jumper wire from the ground rail on the breadboard. Let's move on to the Arduino program. When you open a blank sketch on the Arduino IDE, you'll see 2 main functions: void setup and void loop. The setup function is used to initialize and set up the components for your program. It only runs once at the beginning of the program, while the loop function is used for parts of the program that should run continuously. Now, let's talk code. First, use the define keyword. We'll declare 3 variables to assign the pins the LEDs are connected to. This makes it easier if we need to change the pin number. In this way, we only have to change it in one instance, rather than going through our code one by one. Variables that we declare like this before the setup function are global variables and can be accessed by any function in our program. Note that a variable can also be declared by stating the variable type, the variable name, and equating it to the variable in question. Next, we set the pin mode for the LED pins. The pins can either be set to input or output mode, depending on the component connected to it. In this case, we set our pin to output because the Arduino is not receiving any data from the LEDs, rather it is powering the LEDs. In the loop function, starting with the red light, we use the digital write function to turn on the LED by setting the pin to high, and on the next line, we add a delay of 5 seconds. Note that the unit of time used by the Arduino IDE is milliseconds, hence why 5 seconds is written as 5,000. Next, turn on the LED by setting the digital write function to low before adding a delay of half a second. Set the LED to high once more and repeat this until the LED blinks for a total of 5 seconds before turning it off. I want the red light to stay on for a total of 10 seconds and to start blinking when the countdown is about to end. In this case, I decided that it should start blinking at the 5-second mark. You can change this duration based on your preference. Next, use the digital write function to turn on the yellow LED and add a delay of 1 second. Set it to low and add a delay of half a second before turning the LED back on. Repeat this until the LED has blinked for a total of 4 seconds before turning it off. I want the yellow light to stay on for a total of 5 seconds, as it's just meant to inform drivers to get ready. Once again, you can change this if you'd like. Lastly, the green light is meant to have the same duration as the red light. So you can simply copy and paste the code that you used for your red light and edit the first argument and change it to green. Now, connect your Arduino to your computer and upload the code. You should see the traffic light system running smoothly. Now, you've just built your own functional traffic light system and learned some basic Arduino coding terminology. With that, we've reached the end of the video. You can find the links to the Arduino program and the components used in this video, as well as the Hub 360 starter kit in the description box below. Thank you for watching. If you've liked this video, please make sure to like, subscribe, and comment ideas you'd like us to try. See you in the next video.